Welcome to video lesson, students. Today's topic is Pythagoras theorem. Pythagoras, he is the Pythagoras, who is a Greek mathematician who founded this Pythagoras theorem, and he stated the Pythagoras theorem. Before Pythagoras, many of Indian and foreign people also proved this Pythagoras theorem. According to Indian version, Bodhyan Sulba Sutra. In this, Bodhyan also stated the statement for this Pythagoras theorem. He is the Bodhyan theorem in 8th to 6th century. This Bodhyan found the statement for this Pythagoras theorem. According to his version, the square on the hypotenuse is equal to the sum of the squares of other two legs of the right angle triangle, according to Bodhyan Silva Sutra. Now we'll go in detail. Even before this, also the Egyptians, in construction of these pyramids, they used this principle, Pythagoras principle. Like building up this Egypt pyramids, they used this Pythagoras symbol statement. According to this Babylonian clay tablet found in Mesopotamian region, they found that the Pythagoras triplets were projected on this clay tablet. So this is a Babylonian clay tablet, which was found, this was made in 1800 BC. So according to this, we can say that Pythagoras is not only the first person who introduced this Pythagoras theorem. So Pythagoras is not the only the first person who used this Pythagoras statement or principle. Let us see the statement and let us try to understand the principle behind this Pythagoras theorem. So according to Pythagoras theorem, the statement is, in the right angle triangle, the square of length of the hypotenuse is equal to the sum of the squares of lengths of other two sides. So this is a right angle triangle, and we say the biggest side of the right angle triangle is hypotenuse. So when you, this side square, when you take this area will be equal to this area and this area. So when you add these two areas will be equal to this area. Let us see how they are equal. See this area, the area on the hypotenuse, the square of the length of the hypotenuse is equal to the sum of the squares of other two sides. See here, the square on the hypotenuse is equal to the sum of the squares of other two sides. What are the other two sides? One is AB and the another one is BC. So when you add these two will be equal to this. So according to this Pythagoras theorem statement, he says that the square on the hypotenuse is equal to the sum of the squares of other two sides. See, AC square is equal to AB square plus BC square. See, let us see through this visual description. See here, this is the square which is which we have seen on the hypotenuse. So this must be equal to, when you add these two, you should get the squares on this, isn't it? So let us see, are they equal or not? See here. So this one, 3 by 3 squares, and here this is one, and this is one, and this, and this. So when I moved all this and I adjusted on this big square, it is sufficient. So no other projections we see in this. So by this you can say that the square on the hypotenuse is equal to the sum of the squares of either other two sides. This is the square which we observe on the hypotenuse is equal to the sum of the squares of these other two sides. See here, this is 3 by 3, this one is 4 by 4, and this one is 5 by 5, isn't it? So here we get how many square unit boxes here? This is 3 by 3, no, this is 9, and here 4 by 4, no, this is 16. So 9 plus 16 is equal to 5 by 5, that is equal to 25. So according to this Pythagoras theorem, we can say that the square on the hypotenuse is equal to the squares or sum of the squares of other two sides. So this is widely applied at every area in mathematics application in our daily life. See here, we can observe a building. This is a building, and this is one more building. So some accident has occurred on top of the floor of the building. So how to reach that top floor? So what will be the distance between the tops of the building? For finding out this, we apply this Pythagoras theorem concept. So if we know the distance between these two buildings, and to find out the lengths of the length between the tops of the building, we apply this Pythagoras theorem in our daily life. So distance between the tops of the building, if the distance between the buildings is known. One more example, see this person. This person is painting on the wall with the help of a ladder. So what will be the length of a ladder? What will be the length of a ladder to reach himself to top of this board? So to paint almost at the top of the board, so what will be the length of the ladder should be taken? For this calculation also, we use this Pythagoras principle. So we all see this tents, isn't it? So to build this tent, to find the length of a rope, so this tent is built with the help of a rope. So to find the length of a rope that will taut to the stake, this is a stake. See, this is a stake. To taut this rope to the stake, so what will be the length of a rope? For calculation of this also, we use the principle of Pythagoras theorem. So everywhere in our daily life, we use this Pythagoras theorem. We use this Pythagoras theorem in our different areas of mathematics also. In real numbers, we use in coordinate geometry also. For finding out the distance formula, we apply this Pythagoras theorem principle. In calculating in mensuration, calculation of slant height of the cone, if the radius and height is given, for that also we use this Pythagoras theorem concept. In trigonometry also, 3 tan theta is equal to 4. So how to find out the angle, that is theta value, in that problem also we apply this Pythagoras theorem concept. So this is the introduction of Pythagoras theorem. I think each and every student has understood the principle behind the concept of this Pythagoras theorem, and we will discuss some of the problems in the next session. Thank you.